Hello students, welcome to solution question part 2. So in this question session we will practice question from 9 to 16. So that comprises total of 8 questions. Now after reading each question slowly and loudly, I will give you 10 seconds. So utilize both these times to solve the question. Then you will see the solution that whether you have solved it correctly or not. If not, if you're not able to find the answer, just we can just clarify that your approach was correct or not. So with this, let us start our today's session. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the creators and owners of these images. If you are the owner of any of the images used in any slide deck used in this deck and have any concerns or issues, please contact us at sathi@itco.ac.in and we shall remove the images. Question number 9. At 100 degrees Celsius, benzene and toluene have vapor pressure of 1375 torr and 558 torr, respectively. Assuming these two form an ideal binary solution, then calculate the mole fraction of benzene in vapor phase at 1 atm and 100 degrees Celsius. Your options are A 0.247, B 0.753, C 0.447, and D 0.553. So what is the question saying? So question is saying that we are at 100 degrees Celsius. What are we doing? We are taking benzene and toluene and they have a vapor pressure of 1375 and 558 torr. Okay, now we are taking both of this separately. Next, we are mixing these two and assuming that they form a ideal binary solution, and in that case the mole fraction of benzene is given as 1 atm. Okay, in vapor phase it is given as 1 atm. So this is the mole fraction of benzene in vapor phase, not in the solution but in the vapor phase, and it is given as 1 atm and at same temperature. So what you have to calculate, you have to calculate the mole fraction. Okay, so the say the most important clue for this reaction, for this question, would be that you should remember that this is vapor phase. Okay, this is the vapor mole fraction in the vapor phase, not in the solution. So if you are good means if you are doing the remembering this and you are using the formula accordingly, which is for the mole fraction in the vapor phase, then you can easily solve the question. Clear? So let us start the timer. Your time starts now. Your time is up. Let us see what is the solution. So for those who have solved, the correct answer is C. Now suppose we are assuming that chi1 is the mole fraction of benzene and 1 minus chi1 is the mole fraction of toluene. Therefore, what is P total? It was chi1 P1 naught minus 1 minus chi1 P2 naught. It is directly from the Raoult's law. Now we know this is 760. This is the total pressure it is given. Okay. This is 760 mm of Hg because 1 atm is equals to 760 mm of Hg, and this is given as 1 atm. Then chi1 into P1 naught. Okay. P1 naught is the, so I have told you that these are what? These are the pure form. Means vapor pressure of the pure form. So they are, this P01 and P02 denotes the same thing. So we put this thing, so that help us to calculate chi1. Simple. Now mole fraction of benzene in vapor phases at 1 atm is what? It is y1 chi1 P1 naught by P. Okay, so this is the formula. How it is coming? Because P1 equal to what? Y1 P1 total, where Y1 is the mole fraction in the vapor phase, P1 is the pressure, and P total is the total pressure. And now since we know P1 here, and how will we know? Because we have calculated chi1, so we can calculate P1 also. So chi1 into P1 naught is P1, so we have put it here. And total pressure is P 760, so we have put it here, and then we got 0.477. So what is the overall question? Way to way to solve the overall question. So first you need to calculate chi1. Okay, first thing, because you are being asked or chi1 or the mole fraction of which one, or the mole fraction of say benzene. Okay, you are calculating the mole fraction of benzene. How are we calculating it? So using this formula, we have P total equal to chi1 P1 naught by 1 minus chi1 P2. So this is law of Dalton's law of partial pressure and your Raoult's law. You have applied both of this because total pressure is the individual sum of the pressure contribution, and individual contribution is coming from chi1 p1 naught. Once you calculate chi1, you note the formula p1 equal to y1 p total, and you are again putting p1 is equals to chi1 p1 naught. Okay, therefore y1 equal to what? Y1 equal to chi1 p1 naught by p, where p is the total pressure. Therefore chi1 is already calculated, p1 naught is given 1375. We put all of this, we get it as 0.447. Clear? Moving on the further question. Question number 10. A solution of 2% which is weight by weight, means in 100 gram of the solution we have 2 gram of the solute and rest are the solvent. So 2% is non-volatile solute and they exert a pressure of 1.004 bar. At the boiling point of the solvent, what is the molecular mass of the solvent? Okay, so options are A 0.3655, B 36.55, C 41.37, D 40.16. Clear? So the question is saying that you have an aqueous solution which is having 2% weight. So I have already explained what it is, and you have to see, and this thing is exerting pressure. The solution is exerting pressure of 1.004 bar. So P total is given, and that is at the boiling point of the solvent. Clear? So this is the pressure that is being exerted by the solution at the boiling point, right? So this is given. So what you have to calculate? You have to calculate the molecular mass. How you will calculate? So for this, the hint would be that since you are adding a non-volatile solute, your vapor pressure is decreasing. But and how can we know it? So see, at the boiling point, its vapor pressure is not equal to the atmospheric pressure. It is less than that. So you will use the formula accordingly, which is related to this thing, which is relative lowering of vapor pressure, and then you can solve it easily. Okay, or else you can use that. Yeah, this formula is good enough. So you can use this formula. So your 10 seconds to solve this question starts now. So your time is up. Let us see the solution. For those who have solved, the correct answer is C. Clear? No problem. Now for those who have not solved, your P naught should be 1.013 or 1 atm at boiling point. I have told you that at boiling point your vapor pressure of the solution should be equal to the vapor pressure of the atmospheric pressure. So that is the criteria for boiling, but it is not so. It is less than that. So this is P naught. So what is weight of solvent? 100 minus 2, 98. Okay, very clear. Why are we calculating weight of solvent? To get the molality, because relative lowering of vapor pressure requires this. Now next thing is we know that P naught minus P1, which is lowering of vapor pressure relative to the pressure that it should have, is equals to W solute by M solute, which is mole fraction. Okay, we are not calculating molality. Sorry for that. We should need mole fraction divided by molar mass of solvent by weight of the solvent. Clear? Okay. So put all these things. So this is P naught. We know it should be 1.013 as it is. What we get 1.004. We put this thing also. We are making an aqueous solution. So water is the thing, and whose mass is 98 grams and molecular weight will be 18 grams. But we don't know the molar mass of the solute, and we have to calculate this. So putting all these values, we get this equation like this. And further, on calculating it, we get it as 41.37 gram per mole as the correct value of molar mass of the solute. Clear? This question is clear to you? So this is question. This correct answer is C. Therefore, now moving on to the next question. Question number 11. The vapor pressure of pure benzene is 119 torr, and that of toluene is 37.0 torr at the same temperature. The mole fraction of toluene in vapor phase, which is in equilibrium with a solution of benzene and toluene having a mole fraction of 0.50. So what you have to calculate? So you have to calculate the mole fraction of the toluene in the vapor phase, not in the solution, right? So you will use the formula P1 equal to Y1 P total. First hint. Second hint is that you can calculate the P1 by using the Raoult's law formula P1 equal to P1 equal to P naught 1 X chi1, right? And at the same time, what is given? The mole fraction of the say solution of benzene and toluene is already given. This is 0.50. Now you will get confused that it is 0.50 for whom, right? It is not given here. But see, it is 0.50, it is half. And you know that total it is equal to 1. So for both of them it will be half. So if one is the total value, and if you know that one is having half value, the other will obviously have the half value. You don't have to worry about it, that from which you have to assign it. Clear? Now your options are 0.137, 0.237, 0.435 and 0.205. So your 10 seconds to solve this question starts now. So time is up. Let us see the solution. For those who have solved, the correct answer is B. So we know that for an ideal solution, it follows the Raoult's law and the Dalton's law of partial pressure. So P total can be written as PB plus what? P total can be written as PB plus the PB means of benzene plus toluene. Okay, PB plus P toluene. Now for PB, we can calculate PB from the Raoult's law, that is P naught B chi B, and in Raoult's law calculation can be used again to calculate the P of what? Toluene, which is P naught T plus chi T. P naught T into chi T. Now putting all this value and putting chi B is equals to 1 minus chi T. Why we have put this? Very simple, because all the fraction would add up and give to 1. So this is 0.5 and this is also 0.5. Now upon doing this calculation, we get a 78 torr as the total pressure. Next thing, we know this formula, which is for calculation of mole fraction of toluene in the vapor phase. And what is the formula? So we know that P1 equal to Y1 P total, where Y1 is the mole fraction in the vapor phase, or we can represent it using this also, chi T in the bracket V. So this is what? This is your vapor pressure of toluene divided by the P total. So the value will come out to be 0.237 as your answer. Next question. Moving on to the next question. Question number 12. Question number 12 says that on mixing heptane and octane, they form an ideal solution at 373 Kelvin. The vapor pressure of the two liquid components are 105 and 45 Kelvin respectively. Vapor pressure of the solution by mixing 25 gram of heptane with 35 gram of octane will be how much? Clear? So your options are 72.0 kilopascal, B 36.1 kilopascal, C 96.2 kilopascal, and D 144.5 kilopascal. So how we will solve this question? So what are we doing here? So the vapor pressure of two liquid components are already given, and the vapor pressure of the solution by mixing 25 gram of heptane and 35 gram of octane is to be calculated. A total pressure is to be calculated, and the mass is given. So you will simply apply the Raoult's law, right? Very simple. Okay, so you know the pressure that is due to the pure one, and you know the mass also. Calculate the mole fraction because you know the compound. So your 10 seconds to solve this question starts now. Your time is up. Let us see the solution. For those who have solved, the correct answer is A. So we know that Pt equal to chi h P naught h plus chi o P naught o. Okay, using Dalton's law of partial pressure, we can write in terms of heptane and octane the total pressure. And for them, we have used the Raoult's law to write their respective vapor pressure in terms of pure solvent or pure solute. Now, chi h can be calculated further. Very simple, 25 by 100 by 25 by 100 plus 35 by 14. How we have calculated it? Because the mass was already given, so we are dividing it by the molar mass, and to calculate the total moles we are doing the same thing. So that gives us 0.45. What about the next? So chi o is simply the 1 minus of 0.45, that is 0.55. So we know mole fraction of each of this. We put it in this equation, back in this equation, and that will give you the P total, which is 72 kilopascal. Clear? This question is clear to you? So how we will solve it? Now moving on to the next question. A binary liquid solution is prepared by mixing N-heptane and or ethanol. Which one of the following statement is correct regarding the behavior of Solution. The solution form is an ideal solution. The solution is a non-ideal solution showing positive deviation from Raoult's law. The solution is a non-ideal solution showing negative deviation from the Raoult's law. And heptane shows positive deviation, while ethanol shows negative deviation. So you have 10 seconds to solve this question. So I'm not giving a hint because it is a very easy question and theoretical one. Your time starts now. So your time is up. Let us see how can we solve it. For those who have solved, the correct answer is B. So what happens here, that pi heptane and ethanol form non-ideal solution. Okay, because one is somewhat polar and one is one is somewhat polar and the other is totally non-polar. And as a result, the interaction is low, and as the interaction is less, the molecule will find it easy to escape and hence increasing the vapor pressure. So we can say the resulting solution will show deviation for Raoult's law, and it will produce positive deviation. Clear? Now moving on to the next question. Question number 14. If liquid A and B, two liquids A and B form minimum boiling azeotropes at same specific composition, A, AB interaction is stronger than A and BB, vapor pressure of solution increases by more number of molecule of solution A, and B can escape from the solution. Vapor pressure of the solution decreases because the number of molecules of only one liquid escape from the solution. AB interaction are weaker than those of AB and BB. So your 10 seconds to solve this question starts now. So your time is up. Let us see how we can solve this question. For those who have solved, the correct answer is D. So what happened that in case of minimum boiling azeotrope, the interaction show between two components is needed weaker because it shows the positive deviation. You know it that minimum boiling azeotrope show the positive deviation. For that reason, your interaction that should be there, it is less than the ideal one, and that results in the escape of your say species, and hence your positive deviation. Clear? So this results in a lower boiling point for the mixed vapor to the individual component. Now this azeotrope thing is used, but it has no use here. So basically when you will study azeotropes, they can have two types, minimum boiling azeotropes and maximum boiling azeotropes. The speciality of azeotrope is that they can maintain the same concentration in the vapor and liquid phase as well. So this is for question number 14. Moving on to the next question. Question number 15. An unknown compound is immiscible with water. It is steam distilled at 98 degrees Celsius. At 98 degrees Celsius, P0, H2O are respectively 737 and 707. This distilled was 75% by weight of water. The molecular weight of the unknown compound is, your options are 318.15 gram per mole, B 300 gram per mole, C 306.76 gram per mole, and D none of this. So this question it is written that the compound is immiscible means not soluble in water, and at 9800 degrees Celsius, 98 degrees Celsius, P and P0 H2 are respectively 737 and 707. The distilled water was 75% by weight. The molecular weight of the unknown compound will be. So you have to find it for the solute thing. Okay. So 10 seconds to solve this question starts now. So your time is up. Let us see how we can solve the question. For those who have solved, the correct answer is A. So since the compound is immiscible, hence the vapor pressure is directly proportional to mole. Therefore, P total is 737 and P naught H2 is 707. It is already given. Therefore, P unknown will be this minus this, that is 32. Now, P naught of unknown by P naught of water equal to N of unknown by N of water. Okay, we have written this. Now, putting all the values, we get the value of the required thing, which is your what? Which is your M unknown. Clear, molecular weight of the unknown compound, and that would be how much? That would be 318.15 gram per mole. Clear? Now moving on to the next question. The relative lowering of vapor pressure of an aqueous solution containing a non-volatile solute is 0.0125. The molality of the solution is, very simple question. So options are A 0.69, B 0.50, 0.80, C and D is 0.40. So the relative lowering is already given and you have to find the molarity. So 10 seconds to solve this question starts now. I'm not giving any hint because it is an easy question. So let us start the clock. So time is up. Let us see how can we solve it. You have to find the molarity. So it comes out to be A. So this is the formula. P01 minus P1 equal to P dot by is equal to chi2. So chi2 can be calculated as m into m by 1000 into m into m. Clear that 1000 is always greater than m into m1. Right? So if you put all of this, you will get P01 minus 1 P1 by P0 is equals to small m into capital M by 1000. So that will give you your m, which comes out to be 0.69. So this is your molarity, right? So you were calculating molarity and it is your molarity. So this was all for today's question session. With this, we have completed the last question. Thank you.